Right, this particular section of our flipbook does not have an essential question. Actually, what it's just demonstrating is, what does it mean by having corresponding parts when we're dealing with similarity? So a couple of things you want to note here, something we've probably already covered in videos, but I just want to have you write it again to get this fixed in your mind. The properties of similar images. The corresponding angles are congruent. Corresponding sides are proportional, which means they have the same scale factor. So here's our way to remember this is same shape, different size. And that is different from congruent images or congruent shapes, which are going to have the same shape and the same size. So there's your property of similar images. And then we're going to introduce not only corresponding parts in this video, but also this idea of similarity notation. This is a way of writing mathematically that two particular shapes are similar to each other. And here's your definition. When writing that two shapes are similar, the position of each vertex letter must match the position of its corresponding vertex. So write that definition down, pause for a moment to write that, and then continue on once you get done, because in the continuation right after that I want you to see, here's an example of a similarity notation. If triangle ABC is similar to triangle XYZ, by writing this statement the way we did, class, we are actually telling you a lot about these two shapes. In this case, these are both triangles. We're telling you, one, that we know which vertex matches up with which vertex. The vertex A in first position automatically corresponds to the vertex X, which is also in the first position. And then if we look at B and Y in the second position, those correspond. And then finally the last letter, C, corresponds to Z. When you write a similarity notation statement, it means you are telling somebody that you know which vertex corresponds to which vertex. So because we know that to be true, then we know a couple things. Number one, we know what the similar angles are. So that means we know that angle A must be congruent to angle X. That's first position, first position. We know that angle B must be congruent or correspond to angle Y. Oops. To angle Y. That's the second position letter. And then the third position, C, we know that angle C must be congruent to angle Z. And we know that because the order of these letters tells us which vertex matches up with which vertex in the two shapes. Okay, the next thing we know is we also know what the corresponding sides are. We know that the first two positions here, we've got AB. We know that is going to correspond to the first two positions of the second triangle in the similarity notation. It's going to be XY. And then we know that the last two positions, B and C, they have to correspond to the last two letters of the second triangle in the similarity notation. That's going to be corresponding to YZ. And then we take the final combination is A and C, the first and the last, AC, and that is going to correspond to XZ. Now, you might think to yourself, you know, what big deal is this? Because I can tell these triangles are in the same orientation, so I know that AB goes together with XY. But you're going to see in the next example, when we rotate or reflect a shape, sometimes it's really hard to tell what vertex corresponds to what vertex, or what side corresponds to which side. So we're going to use similarity notation to help us through that problem. One more thing to note about this is, I want you to see, class, that not only could you have written the proportionality or the ratios of the corresponding sides this way, you could also flip them upside down and it still works. So sometimes you don't know which triangle to put on top and which triangle to put on bottom. In this case, we have no idea what's the pre-image and what's the image. So if you flip these two around, it still holds true. XZ over AC. So in this case, I took the first two positions of the second triangle listed and matched them up with the first two positions of the first triangle. So both of these may have different values, the AB over XY, and look at this, XY over AB is the reciprocal. They're going to have different values, but the proportionality statement will still be true if we flip all of them upside down. What you can't do is this. You can't pick a side from this triangle and put it over the side of this triangle, and then for the next ratio, you start picking from this triangle and go backwards. Whatever you put on the top has to be from the same shape, and whatever you put on the bottom has to be from the same shape. All right, let's take a look at the last part here. We'll take a look at these two triangles. And here's our similarity notation. If triangle EFG is similar to triangle STR, then we should be able to answer these questions. Remember, E matches with S, F matches with T, and G matches with R. What I want you to do, I'm not going to write this, what I want you to do is, I want you to put a circle around E, just one circle, and I want you to put a circle around S. We know that E and S correspond because they're in the first position. Then I want you to put a double circle around F, a double circle around F, and then put a double circle around T, a double circle around T. We know that F and T correspond. We're not going to label R and G because that's the last vertex. There's no labeling, so we know that those two will also match up. So based on this similarity notation, which side corresponds to EF? Well, we know EF is the first two positions. That means it must correspond to ST. So EF and ST match up with each other. See how weird that looks on the diagram because we have a rotation going on here, but with our similarity notation we can totally tell which side matches up with which. Which angles, sorry, not which angles, please get rid of this S, which angle corresponds to angle S? Well, angle S is in the first position here. That means it must correspond to the first position here, and that means it matches up with angle E. And then the last thing, find the missing sides. What they want you to do is write the sides that make our proportionality statement. So EF, first two positions, they match up with ST. Look at TR. TR is our last two positions. That matches up with FG, which is our last two positions on our first triangle. And then which one are we missing? We got EF, we've got FG. Okay, we still have to do the first and the last. So EG over, that's going to go to SR. There's our corresponding sides. And again, I want you to note here in your notes, if you need to make a note of this in your paper, go ahead and do that. These come from, actually put the arrow the other way. The top of our fractions all come from the same triangle. Make sure you understand that so you know you're never going to flip them upside down accidentally. And then in this case, the bottom one's the same way. The bottom sides come from the same triangle, this one here. Top comes from this one, bottom comes from this one. You're not allowed to write EF over ST equals TR over FG. When you flip this around, you've actually changed the ratio and they're not going to be equal. So there is some basic things regarding corresponding parts of similar shapes and how we use similarity notation to describe that.